So for part A, helium has two electrons, meaning that the total spin S can either be 0, that means singlet, or it could be 1, which means triplet. So according to the first Hund's rule, excited states excited states which are triplet will have lower energy than the same excited states than the same excited states which are which are singlets. Fine. So 0 means singlet and 1 means triplet. Fine. So according to the Hund's rule, excited states that are in triplet, which are triplet, will have a lower energy than the same excited states which are singlets. Fine. So then moving on, we have part B. So part B is that carbon in the last subshell in last subshell have has two electrons, meaning S is either equal to 1 or 0, and L is equal to 0, 1 or 2. So using first one's rule, the total spin S is equal to 1, and the state is symmetric. State is symmetric. Now we need to find antisymmetric position part of the weight function. For that, we have L is equal to 0 and L is equal to 2 that are symmetric. So that leaves us with L is equal to 1. That would be antisymmetric or asymmetric. Fine. So the total angular momentum J with the S is equal to 1 and L is equal to 1. So J could be 0, 1, 2. So possible ground states for carbon are 3p2, 3p1 and 3p0. Next, moving forward, we have part C. So for part C, boron has one electron in 2p subshell. Now the ground states will have total angular momentum J is equal to L minus S, for L is equal to 1 and S is equal to 1 by 2 from the previous task. We have J is equal to 1 by 2 and the ground state for boron is 2p 1 by 2. Next we have part D. So ground state of carbon, the ground state of carbon is S equal to 1, L equal to 1. And because of that, we have three possibilities for total angular momentum. J is either equal to 0 or 1 or 2. And three possible states, that is 3p2, 3p1 and 3p0. In the last subshell of the carbon, it has two electrons less than half, so the total angular momentum J is equal to L minus S, that is equal to 0. So the ground state of carbon is 3p0. And nitrogen in its last subshell has 3 electrons, means that the total spin S could either be 1 by 2, 1 by 3, sorry, 1 or 3 by 2. The first rule says that the state with S is equal to 3 by 2 will have the lowest energy. Because the state is the top of the ladder, it is symmetric. This is top of the ladder, so it's symmetric, and the total angular momentum L can be 0, 1, 2, 3. And second hand rule favors L is equal to 3, but the state is symmetric. Same reason why S is equal to 3 by 2 is symmetric. Fine. So the antisymmetric state is only antisymmetric state would be when when L equal to 0, then we have the only antisymmetric state. Antisymmetric state. Fine. And because nitrogen has 3 electrons in the last subshell, that is exactly half the total angular momentum J would be equal to L minus S, that would be 3 by 2. So the ground state for nitrogen would be S 3 by 2. So this is your solution.